And we then broke down the responses we looked at into the metabolic responses, the molecular responses, and the actual cardiovascular responses as a whole. When we think of the cardiovascular system, the measurements of cardiovascular fitness that we get are a product of all these different things, but the cardiovascular system is inherently the heart and the vascular system itself. So we broke down what was happening at the muscular level, i.e. the metabolic and the molecular components, and the cardiovascular components, which were the vascular and the myocardial, or the heart responses. So the first thing we started to look at was, what is the oxygen cost of resistance training to momentary muscular failure? So traditional recommendations are, if an exercise is going to improve your cardiovascular fitness, you need to achieve a certain percentage of your VO2 max during it. So if we got you doing, on a treadmill, running at 80% of your VO2 max and measured the oxygen that you were using, it should be roughly about 80% of what your measured VO2 max is. And recommendations are usually anywhere from sort of 70 to 80% in most physiology textbooks and review papers that you'll look at. On the contrary, though, a more recent review has shown that actually the actual relative percentage of VO2 max is not important. And one of the problems with that is, if you look at the paper, is that most people measure whole body VO2 max instead of looking at the oxygen cost of the actual muscles that are working. So what we did was we tried to take the studies that have looked at resistance training to failure and those that have not controlled for it properly. And one of the problems with the oxygen cost responses is that most of the studies are all over the place. So what we found was that most studies included rest periods and all these other things, and gave false impressions of a really low oxygen cost percentage during resistance training, even when it was taken to fatigue, because they hadn't controlled their methods properly. So just eyeballing the research in that area, you would get the impression that, oh, well, if you take the assumption that you need a high percentage of your VO2 max to improve your cardiovascular fitness, then resistance training provides a really poor stimulus to that. But again, that's a huge assumption. So what we started to look at instead was to try and break it down into, well, what's actually happening metabolically when we train the muscle really intensely? And the reason I got Doug involved on the paper is because, although I had kind of had these ideas brewing in my mind for a number of years, and I kind of had a basis for conceptualizing them, Doug's book, Body by Science, really kind of pinpointed it and gave me a kind of framework to think about it in, especially with regards to the actual metabolic responses that go on. So most of the time when we think of metabolism during exercise, you can roughly break it down into, you've got your anaerobic metabolism, which is energy production in the absence of oxygen, and you've got your aerobic metabolism, which is energy production in the presence of oxygen. Now, most exercise recommendations will, again, draw this kind of false dichotomy between the two. They'll say there's a kind of spectrum that if you're working at a very low intensity, you're working aerobically. If you're working at a high intensity, you're working anaerobically. So if you're working anaerobically, you can't improve your aerobic or your cardiovascular fitness. And if you're working somewhere in between, then you might be able to get the best of both worlds. But what that does is it avoids the fact that anaerobic metabolism actually feeds in to, just broke my pointer, feeds into the anaerobic processes. So I would recommend actually purchasing a copy of Body by Science and going through the diagrams in there, because it presents it very well, and the paper, it goes into a lot more detail in terms of the biochemistry, or having a look at Doug's presentation next year. But basically, the end products of anaerobic metabolism have to enter the mitochondria, which is the part of the cell that does aerobic metabolism. And that's how aerobic metabolism works. Anaerobic metabolism feeds into it. So even at this other end, when you're working predominantly aerobically, as they say, you've still got anaerobic processes going on. At the other end of the spectrum, when you're working maximally anaerobically, your aerobic system will be running maximally as well. The only difference is the proportion of energy that each is providing. So at the end of the spectrum, both anaerobic and aerobic metabolism will be working maximally, But anaerobic metabolism can ramp up and increase the amount of energy it provides exponentially compared to aerobic metabolism. Aerobic metabolism has a limiter on it, basically. There's an enzyme that limits the amount of this end product from anaerobic metabolism, the rate at which it can enter the mitochondria, and therefore the rate at which you can aerobically metabolize and produce energy. So what you have is, working at maximal intensity, you have a maximal stimulus to your anaerobic metabolism and a maximal stimulus to your aerobic metabolism. And that seems to be limited by this enzyme. So as long as you're working the local muscles maximally, so let's take, for example, you're performing a leg extension exercise. Exercise physiologists love leg extension exercises in research just because it's really easy to control, and most labs have a leg extension machine. So let's say you perform repetitions to failure. If we were to measure your VO2 max, i.e. the amount of oxygen you're taking in and using for aerobic metabolism, it would appear to be relatively low if we compared it to your whole body VO2 max. So let's say, for example, we did a VO2 max test on a treadmill. We got you to run until you pretty much collapsed and measured the maximal amount of oxygen you could take in. Problem is, you're comparing apples and oranges, because in the leg extension exercise, you're measuring the maximal aerobic metabolism, or the maximal oxygen consumption being used by the muscles in that exercise. And you're then comparing it to the maximal amount of oxygen that you can take in and utilize when you're using loads of other muscles as well. So what's actually happening is, although relatively, if you compare it to your VO2 max on, say, a treadmill or a bike, it would appear you're using a very low percentage of oxygen, you're actually working those muscles maximally in terms of their oxygen consumption. So that provides a really strong stimulus to the aerobic components of the muscle there. What you've also got then is, as you start to work maximally, the products of anaerobic metabolism can't enter the mitochondria as quickly as they would like to. They start to stack up in the cell, and something's got to be done with them. So they get converted to lactate, essentially, for a variety of, for a series of biochemical reactions. And that lactate can start to interfere with muscular performance and contraction. So the body's got to try and deal with that, otherwise it will start to inhibit the amount of work you can do. And another thing that can start to improve your endurance performance and your cardiovascular performance is an increase in your body's ability to deal with that. Now, this is one of the areas that there's not actually been a great deal of research being done on. So some of the stuff we suggest in the paper is speculative and does suggest that more research needs to be done on it. But it does appear that you can start to improve your lactate threshold, as we call it, the body's ability to take those byproducts and deal with them more efficiently through performing resistance training to momentary muscular failure again. So all of these different things that we look at on the metabolic side of things are all being maximally stimulated when we work a muscle to fatigue. It doesn't matter what the mode of exercise is. It doesn't matter whether you're on a bike and you're doing sprints until you can't move the pedals anymore, or if you're on a leg press and you're doing repetitions until you can't move the weight anymore. It's all the same at the metabolic level, at that physiological level.